Shown in figure is a three-phase star-connected induction motor equivalent circuit. Okay, the motor has stator impedance of 0.06 plus J times of 0.2 ohms and an equivalent rotor impedance of 0.06 plus J times of 0.22 ohms. Okay, neglecting the current, what is the slip at which maximum gross power can be delivered? Okay, he has given the stator impedance means what is the stator impedance 0.06 plus J times of 0.2. So what is the total resistance we have? Stator plus rotor is 0.06 plus 0.06 in stator and rotor winding. So this is 0.12 ohms. Similarly, what is the total reactance present in stator and rotor? Xt is equal to x1 plus x2 dash, which is equal to 0.2 plus 0.22 0.42 ohms. So what is the total impedance, that is rotor is referred to stator plus stator winding as 0.12 square plus 0.42 square, which is equal to 0.44 ohms. Now what is the slip present at which maximum gross power which can be delivered? So this is given as R2 by R2 plus Z0 1. What is the value of R2? 0.06 plus 0.06 plus 0.44. This is equal to 0.12, which is equal to 12%. So option C is the correct answer. Transformer is connected to a 1000 volts 50 hertz supply. The total core loss is 1000 watt, of which 700 are hysteresis and 300 watts is eddy current loss. If the applied voltage is raised to 2000 volts and frequency is equal to 100 hertz, what is the new core loss? Okay, earlier he has applied voltage of 1000 volts, okay, with frequency of 50 hertz. So V by F is equal to 2. Similarly, after that, voltage is raised to 2000 volts, whereas frequency is raised to 100 hertz. So V by F ratio is equal to 2. So that means the V by F ratio is constant. Okay, if V by F ratio is constant, a core loss is given as hysteresis plus eddy current loss. Okay, when V by F ratio is constant, hysteresis loss is directly proportional to frequency F, whereas eddy current loss is proportional to F square. Okay, if V by F ratio, which is nothing but an B max. Okay, generally hysteresis loss is directly proportional to B max power 1.6 into F. If V by F ratio is not constant, then what this one? It is directly proportional to V power 1.6 F power minus 0.6. Similarly, hysteresis loss is directly proportional to Bm square into F square. When V by F ratio is not constant, this is directly proportional to V square. So we should not use this formula since this is valid for V by F is not equal to constant. So we have to use only these where V by F is equal to constant. So I can write this one as WH2 by WH1 is equal to F2 by F1. So what is hysteresis losses 2? Hysteresis losses 2 is equal to hysteresis losses 1, okay, which is of 700 watts. So this is 700 into 100 by 50, which is equal to 1400 watt. Similarly, WE2 by WE1 is equal to F2 by F1 whole square. So I can write hysteresis losses 2, that is at 2000 volts, is equal to hysteresis losses 1 is 300 into 100 by 50 whole square, which is equal to 1200 watt. Now what is the new core loss? WC2 WH2 plus WE2, which is equal to 1400 plus 1200, which is equal to 2600 watt. So option D is the correct answer. A bus matrix of a 100 bus interconnected system has 90% sparse. Hence, the number of transmission lines in the system must be, okay, suppose if you have a Y bus matrix, generally this matrix is rated for n by n. Okay, here number of buses is equal to 100, so this matrix is of order 100 by 100. Okay, so total number of elements is, total elements in this matrix is 100 into 100, which is equal to 10,000 elements are present. Okay, all these elements, let us take, see here, this is transmission line 1 2 3 4 so on to 100. Similarly, number of rows are 1 2 3 4 so on to 100. Okay, suppose if you have a 3 bus system, let us take this as 1 2 and 3. Okay, the interconnection of the buses, let us take it as like this. Now transmission line means it is connected between two buses. Okay, let us take this transmission line, it is connected between 1 and 2. Similarly, this is a transmission line connected between 1 and 3. Similarly, this is a transmission line connected between 2 and 3 as well. Okay, see here, transmission line means it is interconnection between two nodes. We can treat each bus as a node, so it is interconnection between two nodes. Okay, out of these 10,000 elements, 90% is sparse. That means only remaining 10% has non-zero elements. What do you mean by sparse? The entry is 0. Okay, most number of elements in this 100 by 100 matrix is zeros. Okay, only 10% is having non-zero elements. So 10,000 into 10 by 100 is equal to 1000. Out of these elements, 10,000 elements, these are non-sparse elements. That means non-zero entry elements we are having. Okay, now how many number of self-admittance elements are there? All diagonal elements are called it as self-admittance. Remaining are called as lower and upper triangle are called as mutual admittance values. So how many are there? These non-diagonal elements are exactly 100. So number of self-admittance elements for 100 bus system is equal to 100. Okay, so number of transmission lines, so non-zero elements are nothing but in transmission lines. Okay, 1000 minus 100, which is equal to 900, because these are non-sparse elements. Okay, self-admittance means, what is self-admittance? Suppose this is having transmission line of admittance y1, y2 and y3. Self-admittance at bus 1 is y1 plus y2. Similarly, self-admittance at bus 3 is y2 plus y3. Similarly, self-admittance at bus 2 is y1 plus y3. So we have to subtract non-zero elements, non-zero entry elements from these self-admittance matrix elements. Okay, so it is equal to 1000 minus 100 as 900. So number of transmission lines in the system must be 900, which is option C. Y bus matrix of a 100 bus interconnected system is 90% sparse. Then the number of transmission lines in the system must be. Okay, now Y bus matrix is of order n by n, where n is equal to number of buses. Okay, in question he has given as it is a 100 bus system. So total number of elements in n by n matrix is, total number of elements is n square. So this is 100 square, which is 10000. So there are 10,000 elements in this Y bus matrix. Now this Y bus matrix is 90% sparse. Now what is sparse? If element entry is equal to 0, okay, then it is called as, if more number of elements are 0 in the matrix, then it is called as sparse matrix. So out of this 90% are sparse. So number of non-zero elements, okay, that means only 10% of the Y bus matrix is non-zero. So this is 100 into 100, that is 10,000 into 10%. So this is 10 by 100. So number of non-zero elements is 1000. Okay, now what we have to find here? Number of transmission lines. Now transmission line is connected between two buses. Okay, like this. Between any two buses, transmission lines will be there. Okay, so what is out of these 1000 entries? Okay, how many self-diagonal elements are there here? Self-diagonal elements are, since it is n bus systems, n by n matrix system, okay, total number of self-diagonals is equal to n. So n is 100. So number of transmission lines in the system is
900, which is option C.